Oh, yeah, that's fine. That's fine. Not
Like I tried to like at least do the problem of the day, like to maintain the streak.
yeah, yeah. That's
Just if I get time.
yeah. I'll just admit everyone, and yeah, I think four people are here, so we'll start at 10, around 10. Yeah. Uh, so today we're just going to do a system design of WhatsApp, right? And I want us to do it together, right? Like all four of us, Parag, Yashas, Nav, Shreyam, right? Yeah, yeah. So I was hoping we will do one question earlier, right? So imagine a chat app, right? Let's say there is a chat app. This is actually a real thing that I was thinking of. So there is a chat app, right, where let's say you send a hi, right, and you send a URL, right, like let's just say you have a website, right, sneakers.com, right, you have this link on this chat app. You're just sending this link, and what this app will do is that it's going to um, generate test cases in the front end for you, right? So let's just say this is like your app, right? There are some buttons here. So let's just say it's going to click a button and login screen light. So it's going to click on a few buttons and do the login, and then like generate a test case for you based on that. So like how using OpenAI, do you guys think how you could like think about it? Hello. Okay, we'll
Hey Ramit, can you please like tell the question again?
Sure, sure. So there is an app, okay? There is an app, right? And in this app, basically, you enter a URL, right? You enter a URL, and this app is like this. And this app is going to scrape, not scrape. This app is going to use OpenAI to basically find out, like, how do I say, so generate test cases, right? Generate front end tests based on generate front end test. It's going to generate a set of random front end tests using OpenAI. Like you just enter this URL, it will generate a case like where you do the login, right? Something like that. Like from a high level design perspective, so just think about this. We are not going to solve this right now, right? But I hope this question is clear. I'll enter it in the chat also. We'll discuss it later, right? After the session is done, right? So today we are going to do a system design of WhatsApp, right? And I want us to do it together, right? So let's just say that you have been given this question. What are some of the requirements that you can think of? Let's list down, right? Functional requirements. Yeah. Anyone?
Basics can be like starting, sending and receiving text messages.
Yeah, exactly. Sending, receiving text. Okay. What else? Let's just reduce this.
One could be peer to peer, one could be like like broadcast or group. Does that come under functional requirements?
Definitely, definitely. So group message, create groups, right? Create groups, send messages in groups, right? Create groups, send messages in group. Okay. What else can you think of? Okay, maybe I'll say one. We can send media, right? Media and large files, let's just say. not very large files, but larger files, right? Media and stuff. And what else can you guys think of? What else can you do?
What about calls and like video calls, like normal voice calls and video
Definitely,
calls?
definitely. We can do that, but that basically will be a completely different architecture altogether. I mean, it's just going to more
Okay.
complicated. So we're gonna keep it to messages, right? Basically, I think this
Okay.
much is what's basically going to happen, right? Send messages, create groups, send media, larger files, basically from a chat, person to person chat, right? And now, if I look at this, right? If I look at this, let's just say there are two people. I think I've drawn some basics here. Yeah, let's just say there is a person, right? There is a person here in India, right? India, and then there is a person in a different country like US, right? So, like the in very basic terms, my app's function is to enable communication between these two people, right? um, to enable communication between these two people. So now when you talk about chat apps, there are different kinds of, let's just not make it WhatsApp, right? Let's make it a chat app. So I want to understand what are the different kinds of chat app and how do they differ, right? So um, let's say you have something like WhatsApp, right? WhatsApp, and then you have something like um, Signal or Telegram. Do you guys know how these two apps will differ?
Uh, I'm taking Telegram has bots, right? WhatsApp,
No,
they
no,
don't
no,
allow
no, no.
you to use
Just
bots.
based on
Is
these
that right?
functional requirements from an architecture standpoint, how do these two apps differ, WhatsApp and Telegram?
In terms of storing data, like where do they store data?
Exactly, exactly. So you see, when WhatsApp was invented, right, it was invented by a group of 10 people with a very limited budget. So what they had to do was they couldn't have a storage of petabytes and size. So not just WhatsApp, if you look at something like your traditional messaging, right, messaging. So how this works is, if you have a message to send, right, um, let's just say, where is it, yeah, it's a message, right? I'll use this for a better example. So you have this message to send, and Priyansh, okay, okay, six people, very good. Yeah, so let's just say we have a message to send, right? So what happens with WhatsApp is the message goes from this person's device to this person's device, right? It's stored in this device. So there is a small storage in each one's device where it is stored, right? And this message is encrypted. It's encrypted, but WhatsApp does not keep it on its server. Okay, one more person. Hey Shweta, first class. Yeah. Um, so we were just talking about WhatsApp. So yeah, I'll just go back. So WhatsApp does not store it on the server, right? Now when I say WhatsApp does not store it on the server, it doesn't mean that WhatsApp does not store any of it on the server. But what you have seen is that sometimes there are these backups that happen, right? Have you seen these backups that WhatsApp does?
Yeah,
Yeah,
weekly
so
or daily, whatever
yeah,
you said.
yeah. So you don't see that happening with Telegram, right? And you don't see your messages getting lost in Telegram, but when you open WhatsApp from a different device, your message, a part of your messages are lost. So what WhatsApp does is, basically WhatsApp server syncs from your local device, right? From this to here it syncs, and basically it maintains a copy on its storage. But what happens with apps like Signal or Telegram is the data is stored in a server, and whenever this client comes, right, it just pulls the server and it gets the data, right? So the data is not stored on a user's device, right? I hope this difference is clear to you all, right? Difference between messaging, WhatsApp, and apps and cloud storage apps like Signal or Telegram, right? Hello.
Yes, yes. Is it like decentral and central, something like that?
exactly, P2P versus centralized, right? Peer to peer versus centralized, right? So that's kind of the main difference, right? Can you tell me a benefit of both, right? What is the benefit of P2P, like something like what messaging or WhatsApp?
P2P means person to person.
Yeah, something
I
like
didn't get
WhatsApp. So
you.
okay, I'll just do the explaining. The difference between P2P and this something like Signal or Telegram is basically that in P2P, right, there's more security because the data is not stored on the server. Except WhatsApp does, you do the sync, but if you turn off the sync, right, it's stored on your device. It's not stored on the central server, right? That's one advantage. And the second advantage in terms of the company is that with less server cost, you can less database cost, you can run a large number of people, right? So WhatsApp ran with very minimal cost because of that. They didn't have servers that would, overload. But Signal or Telegram, they need large servers, they need large databases to handle the kind of loads, right? Because they are actually storing on the server. It stores on the server means people are polling the server at every time you're opening the app, someone's polling the server, someone's getting all that data, right? So there's billions of reads, writes that are happening at any given point of time. So with WhatsApp, again, right now the structure is different, but with WhatsApp earlier these days, or in messaging also, like your local messaging, just think of the local messaging you have, right? It is not intensive because the data is on your machine, right? So now if I'm to build, now I'm talking about building a very generic chat app, right? If I have to build something like this with these very basic requirements, right, what are the various services I will have to do, right? So I'm gonna do that. Okay, so basically we have, let's just say we have something like there's a microservice architecture that I'm like thinking of, and then we are going to write APIs for each of this, right? So let's just say, what are some actions that happen when you open WhatsApp? What happens? You have just installed the WhatsApp app, you're opening it, just WhatsApp. What is the first thing that happens? Shyam, you tell me.
Authentication.
What happens?
It will ask. Uh, it will ask us for our number with which we want to use
Exactly, but what's happening?
and
It's
register
asking
it.
for your number. Yes, exactly. So it's registration. Okay, we call it user service. Okay, so it's a registering, it's asking for your number, it's doing this registration and all that shit, right? So this service is going to handle your authentication, your registration. Okay, now that you have registered, what is the second thing that the app will do? Hello. Okay, Shweta, you tell me.
It will ask the number and then it will load the previous data if it is already there.
No, you're opening WhatsApp. You have never used WhatsApp before. You're just creating an account. What is the second thing that it does after you have registered?
Profile setup,
Yeah,
contacts,
exactly.
syncing with contacts.
Exactly. It sees the contacts that you have, right, on your device. It syncs with the contacts. So that falls under contact service. Okay. Let's build. So this is the way that you think of microservices, think of components that are disconnected, and then you will see some services come common. Like the authentication is in every app literally. So you have user service, and then you have something like let's say Auth0, right? So when you're building something, you outsource these things. That's how you build microservices. You outsource your authentication to something like Auth0 or Stitch or some other service, right? You have this contact service. Okay. Let's think about it. You have contacts. Okay, this is good, you found your contacts, you synced your contacts and everything. um what's the next thing that you do?
Message.
Message.
Exactly, you send a chat to someone, right? You send a chat to someone, so that will be your chat service, right? So your chat service handles all the messaging part, right? You're sending a message to someone, you're sending a media to someone, right? So now when you're talking about big companies, messaging and media might be two separate entities, but here I'm going to compress them into one. And when we are doing this, you will see that how messaging and media, the architecture differs very much, right, when you're doing messaging or when you're sending a media, right? Okay, so chat service happened, user service happened, then there's contacts, the sending messages, everything's going fine, right? What else can you think of, right? You're sending a chat from this person to this person, okay, like, I'll keep it simple. One last service, right? This service comes in every service. What what can it be? This is not a front end service. This is a back. This is something that you'll hook up to.
Encryption.
Not really. Encryption is something that will stay on your device, right? It's a peer to peer. Again, encryption can be a service, but I'll put it under chat service
Mm,
too. Okay, so this will be your
modifying.
analytics. What?
Okay. No, no. I thought modifying chats.
Modifying, no, that all that falls under chat service and will not make it very complicated.
Uh,
So analytics service, and now analytics service is what it's basically something that comes under all every service, right? Whenever you have something going, you hook it up to a service and it's gonna gather all the data, and then it's gonna use process all that data, right? It's gonna figure out patterns, see what to recommend, or maybe just see how the chats are doing, or do all that shit. So which service out of these three service should I hook up this analytics service to? Out of
Chat.
this, exactly, chat service, right? So the analytics service is hooked to the chat service, because this is where all the chats are happening and everything's happening. So my analytics service is hooked to this service. It's gathering all the data and doing all this. Now we are gonna do a deep dive into each and every service, figure out the APIs, and figure out what kind of contracts we can have, right? So I keep thinking, let's say user service, what can it be? What are some APIs we can have for this? Slash login, maybe, right? Slash register, you send your number, slash get OTP, right? You get OTP, maybe. Then what else can it be? Like, it's the user service, right? So what happens? You enter your number, and you try to get an OTP, and then this register is going to, you're sending that OTP, right? And then there's just this login or register, right? So depending on what you are doing, very very simple service, right? Then let me try to build this service, right? How do you think it handles all this, get OTP and register and login? So it's going to send a message, right? Whenever you try to get an OTP, it's going to basically send a message. So there can be a message queue or something like that, right? Message queue. Just think, there can be a message queue, right? You want to get an OTP, it goes to the message queue, and there's a notification service. Again, I'm keeping it simple, but there could be like a notification service. Sorry. So the message queue is hooked to the notification service. Just thinking out loud. Notification service, right? Because every app needs to send notification. Even apps like WhatsApp needs to send notification. So let's just say this is going to send you a message, right? This service, it connects with your SMTP providers, like it sends you an email, sends you a iMessage or something like that. So this puts this in the message queue, it sends the notification service. This is a whole architecture in itself. It sends you a message, then you hit register or you hit login, right? And it just basically could you guys turn off the sound? There's some sound coming, I think. Yeah, yeah. Great, love the piece. So yeah, we have this, login, register, get OTP, right? Very very basic structure, right? And then what we can get is, we can basically get a user token, right? UUID or something like that, which is a unique identity for the user, or like a session token or something like that, right? That session token is basically something that is going to be used in the other services like chat service, notification service, contact service or something. So now I want to look into this service, contact service. How does the contact service work? So let's just see from that API design perspective, right? So what are some of the APIs that this contact can have? I can think of sync contacts, right? Like, what is something that this app does, right? It syncs your contacts, figures out how many contacts that you have. So it's going to upload all the contacts and then sync it, right? Like upload contacts
You
or
can
something.
create a new contact also, right?
On WhatsApp, I don't think
With
you
pops.
can. Yeah, that's
So
something
we
to do.
we have the facility to create.
Okay, that's in the real WhatsApp. Like again, you can always add APIs, but we are keeping it simple. So in the earlier days, we assume that you're upload adding contact in your normal app. So there is something like upload contacts, which is basically going to take contacts from your address book and upload those contacts. Then you can basically, once you have uploaded, someone joining.
Filter contacts
um, Filter contacts. What does filter contacts do?
in the sense like you block them or view them. Like
view
that's all.
con View contacts, you're saying?
Yeah, yeah,
No, your upload is doing that. So I'm thinking that upload contacts
yeah.
is going to upload all the contacts, right, to your service. That these are the contacts that this user has. It's linked to your UUID, right? So across in this user service, there is a UUID that is generated whenever you register. You get a session token. Using it, you can access all this service. So whenever an API call happens, that will always happen through the user service, right? It's going to authenticate your session and then it's going to go to your contact. So there is always going to be a UUID that is going to be like the common thread for all these databases, right? So when you look at contact service, there's going to be something like upload contacts. Then there can be something like um, let me just think of it. You're uploading your contacts, so these are the contacts. And then um, is contact present for user or something? Like when you're selecting a contact, right, is contact present? Is if you can initiate a chat with that user. Like if this user has this contact in his list, right, then only you get to have a chat with this user, right? Does that make sense?
Yes, yes.
Yeah, exactly. So it's a simple service, contact
Hi,
service. Hello.
I had a doubt, as in the how the sessions are managed, because when we consider a normal application, so after some time we like the system logs out if the user is not active, but in WhatsApp we never get logged out. So how come the session management is done over here?
Yeah, exactly. So
As in
you
the
can have an
session never ends over here, no?
yeah, you can have an infinite session, right? So it's just basically your session token. Once you're done logged in and registering, you get a session token that is infinitely valid, right? Security is not an issue. Whenever you get a new session token, they invalidate the previous session token. So how do you think data is stored in the database in the user service, right? So you have a database where you're basically just stored the session token with the UUID, right? Session token with the UUID. So whenever you're registered or login on a device, you get a session token. When you're registering on a new device, you get a new session token. And on your database table, right? Let me just do this for you, so you guys will remember. And again, this is system design, right? There's a lot of different ways. Like WhatsApp is not built this way, the way that I'm writing probably. So let me delete this column, right? So it's basically like, let me delete this row also. Let's see. Let's delete this row. Yeah. So let's just see. It's basically like your UUID and your session ID, right? UUID is valid for a lifetime, right? It's basically like a, you know, once a user registers, he gets a UUID for his number, and that UUID is valid forever. But whenever he logs into a device, he gets a session ID. So if it's just one device, then it's basically like a UUID and session ID. For one UUID, you'll have one session ID. Whenever you're writing a new one, you're overwriting the session ID, right? And for all these devices, it's basically there is another you know, like slash authenticate. So every other call that's happening, it's first hitting the authenticate and seeing if the session ID is correct or not, right? Does that make sense?
Or is this something
Yes.
that in the headers of the request, the session ID already gets inserted? So
Exactly
it will
what I'm
just
saying, like,
validate from the header also.
yeah, exactly, that is what I'm saying. So it's in the header, right? Whenever you want to send a chat, so it's going to hit the chat service, right? But first it's going to hit the authenticate of the user service, where it's going to validate, and then it's going to go to any other service. So this service is going to sit on top of every other service, right? That's good, that's good. I'm really happy you got that right. So we did the user service, and this is very simple. Like, user service comes in everything. The user service is usually outsourced in, you know, smaller companies, right, to maintain security and other compliance stuff, right? And then we have the chat service, right? So let's talk about the chat service. The chat service is used for sending text messages, and here I am also integrating large files and audio from user A to user B, right? This is where the juice happens, right? So how will you send, if you want to send a simple text message from user A to user B, it's no big deal, right? The entire text code just stay in a single server, right? Let's consider two kinds of system. A is WhatsApp, right? And B is something like Telegram, which stores it in the cloud. So for Telegram, there's basically going to be a table, right? There's going to be a table where, you know, the UUID and the message is basically being stored, right? If I delete this column, let's just say this is UUID and the message, right? There can obviously be other metadata that you can think of, right? Like, what is the positioning of the message, what is the 2%, right? UUID, this is the sender UUID. There's going to be a receiver UUID, right? When you think of it, receiver UUID. So again, I'm not going too much into depth, right? But you can always come up with an architecture where this chat service is going to be stored, right? In case of something like Telegram, this is stored on the cloud. When you are accessing from your device, all this data comes in case of something like WhatsApp, what happens is this data, it's going to go to the chat service, is going to go to something like it's going to go on the device, on the original device, it's going to be pulled, right? And then in the device, it's going to show up in a certain format, right? But so this is simple. You can have a Postgres where, you know, all the data is being stored. um, I'm thinking of it, right? You can have how would you shard this table, if you can, like, partition it into various tables, right? I mean, partition the
Based
database
on location.
based on what?
Location.
Exactly. So you can shard it based on location, based on city, state, or, you know, larger chunks also, right? That's one good thing. And how would chat and media differ? Like, when you are sending a chat, right, how would the architecture of chat and media differ? Like, can you just store media on the same table as chat, as a, you know, zip or something like that? I mean,
Do we
Postgres.
use like a different
What?
server, like file system with file server for media?
Exactly. Not media or file server. So whenever you are sending media, right, or large files across countries, across regions, what we have is something like a CDN, right? So what a CDN does is, this is a US, this is a person based in US, right? This is a different, let's just say he's based here, and some other person is based in some other region in the US, right? So you will have a CDN for each location, right? And what CDN is basically like a cache whenever you're sending large files or something across A to B, right? You will always use a CDN. So most companies, they don't have their own CDN. This is managed by some big organizations who have these CDNs, which are basically just servers. Like AWS has a CDN, right? Servers across the world, right? So whenever this person has something to send, it's basically just going to hit the chat service, right? And the chat service is going to move it to the CDN nearest, right? So whenever this person opens up, he can pull the data from the nearest CDN. That's how he has minimum buffering, right? um, in the chat service, right, if there is a heavy load that's happening, obviously a queue will again come in place, right? Because you are transferring data from A to B, right? Basically that's the basic use case, right? And if there is a million people who are talking at the same time, any server might get choked. So whenever there's a choking scenario that happens, you basically put a queue in there, right, to save that scenario, right? From the API level design, I can think of basic things, right? Send message slash send media or something, things like that, right? Simple things, send message, send media, and stuff like that, right? You have a queue where all the messages and media are going to be pulled, and then it's going to decide the nearest CDN where I have to send it to. If the user is present, he can pull it from the CDN, or if it's something like WhatsApp, that data will just move into his storage, right? Some use cases I can think of sometimes, if the data goes missing from the CDN, right? There's a token that's moved that this data is there, right? Sometimes you open WhatsApp and you see that waiting for this message and it's corrupted, please ask the user to send it again. So what can happen is, I can think of, is the CDN that destroys the message, right? And the CDN or the storage where it is present, and then this user is basically does not have the message right now. He opened it later, or it got deleted from his machine, so he is requested to again ask for this person to send it. So what I can think of is that there is a token that is sent that signifies the message, and then the actual message comes, which is like the message, right? And then we have simple analytics service that basically listens to these chats, and it's in encrypted or unencrypted format, and it just hooks it to something like a big storage, right? So this is how I think we design something like WhatsApp, right? Is there any questions any of you will have?
So I had a question, as in we have the FTP servers as well. So how are they different from CDNs? Are they completely different thing?
FTP servers are used for transferring files, I guess. So I haven't never used an FTP server. CDN is a cache, like server, and this is a different concept if you think of it. CDN is, again, I don't have proper research on what an FTP server is. I know it's used for transferring files, but a CDN is a cache across, which is used for let's just say that you watch Netflix, right? Netflix has a big movie, right? You want to watch that big movie, right? How does it's very big in size. How does, like, and data, right? Data travels. It doesn't travel at the speed of light. It probably travels a bit faster than the speed of sound. So if that movie is going to be stored in Netflix US server, and it's coming to your country, right? It's being streamed like that. If that's the way the data packets are going, it's going to be very, very slow. So what Netflix does is, if you're staying in Mumbai, there is a CDN in Mumbai. Netflix sees that what is the amount of people that are going to watch this movie in Mumbai, and they are going to send that data. They are going to keep that movie in their Mumbai CDN, right? So you will notice that some movies that you play on Netflix are slower than other, or some play in 480p, some play in 720p. Have you noticed this? No one has seen
Yes,
this.
yes.
Yes.
Exactly.
Even
So
YouTube as well, right?
exactly, for any service, that is because you're streaming a video that is not present. Like if you see a Mr. Beast video, it will open up very fast, it will work very fast, because YouTube knows that the demand is going to be there. So they are going to send that, across all their YouTube CDNs, right? So if I'm streaming a Mr. Beast video, I'm probably finding it in the CDN in my neighborhood, right? But if I'm streaming something like a video that some obscure YouTuber has built, like if this video, right, it gets streamed from someone in the US, it's going to stream very slow, because no one has any demand, right, has anticipated that kind of demand, right? So that's how this thing happens, right? It's just a cache, for storing large files, if you think of it, right? And for every system that you design, right, if you give me a system right now, I can tell you, I can put CDN somewhere, I can put a user service somewhere, user service comes everywhere, I can put an analytics service somewhere, right? So these three things are like constants in almost every system, right? And notification service is also kind of a constant. So there's that. um, this is good. I think we did a system design on Netflix on WhatsApp together, right? WhatsApp, Signal, Telegram, we understood. Is there anything else that you guys would want to know about this, like do this about this?
I have a question. So
Sure.
the media is always in the CDN part. I mean, maybe it is there in the Netflix server in US. What about India? So it will be always there in CDN. I mean, it doesn't be there in the data center of India. It will be there, right?
Yeah. So CDN is a cache, right? CDN is a cache. When you need data fast, it's just going to put some data in the CDN so that you can access it fast. Again, data centers are more centralized locations. So I don't know how Netflix India's architecture is, right? They could have their data center where permanent copies of the data are being stored, and then they have the CDNs where they are basically caching those data, right? But any other question about this chat app? Do you think we have done it reasonably good enough, or is there, like, some of you guys give interviews, do you think we can post-mortem some parts?
Can we include search?
Can we include search of what? Search messages?
Search of, let's say, keyword or something.
That's something local. When you think of it, how much
Okay.
chat do you have?
Okay.
What is the volume of chat that you might have? 10,000, 100,000, right? All those algorithms reside on your mobile device, right? See, this is person to
Understood.
person. When you think of a feature like search, that is person to person. You're not gonna search someone else's chat. So then you can store it in a binary tree format or whatever. But it's something that resides in your local device. Your local device can do it for you. But yeah, anything else? Do you think, is this reasonably good? I think for a HLD. Do you guys think? Hello.
Yeah,
Yeah. Okay.
it is.
Okay, that's cool. So just took 30 minutes. Is there one more HLD you guys want to do? Like, you guys give the question, we'll do it together, right? One of you. Yeah. Hello.
Yeah. What were you saying?
Let's do one more HLD, like we did chat app. Let's do something else, right? What can
Okay.
you guys think of?
Can we do a split wise?
Split wise, it's not an HLD problem. It's an LLD problem. Split wise. So LLD is not my thing right now. I'm still studying it. So splitwise is nothing, right? It's something that resides on your device. Like, it's just one server, right? It's just maintaining all those logs across devices. That's an LLD problem. HLD is something where you have a lot of this different components: Instagram, YouTube, Twitter, something like that. Can
How
think.
about something like Hotstar or something? Does that come under HLD?
Yeah, Hotstar, Netflix come under HLD. Yeah, definitely. I did a system design of YouTube, if you think of it, right? Let's do YouTube. Okay, Hotstar works, right? Let's think of all the services, right? Let's make it. So there's a user, right? When you think of it, there's a user. What comes from this service? User service, right?
Registration.
Yeah, exactly. So all those things from user service, I'm just gonna take into the hotstar, right? So user can register, do all this, do that. There's paid users, there's free users, right? Based on that, user will get a UUID. Based on that, he can browse, right? um, what else could we have? User, apart from users, what he can do, he can watch movies, right? So
Analytics.
yes, analytics comes in everything, right? Analytics is there in every service. It hooks up to your user history service, right? What movies the user is watching, what is his watch history, right? And the other services I can think of, right? Just tell me. I'm thinking of something like a movie service. Movie service, right? Whatever movies the user is watching, right? um, yeah, so let's just say whatever movies the user is watching, like it's this is a central database that the data is being stored in, and then we have the cdns near the user, right? So just like I said, just like YouTube works, right? This movie service has all the data, and it's gonna decide that okay, this user is in India, he wants to watch something in India, so it's gonna stream that. It's gonna keep it here, it's gonna keep the movie here, right? Let's assume this is the movie, and then the user can easily find that movie here, right? And we have movie service, right? What else? We have analytics service that hooks to the, actually not the movie service, analytics service, which maintains the user history, if you think of it, right? Let's just call it user behavior service, right? If I can think of it. So if the user is watching a movie, right? How does hotstar work when you log in, right? When you log in, don't you see that you have watched a movie 30 minutes, you've watched a movie 60 minutes, right? So you see that,
Yeah,
and that is,
continue watching.
yeah, just so mute your mic whenever you're done talking, that will help. Hello. Yeah, just mute your mic a bit. Yeah, thanks. uh, Again, some mic noise is coming. Shweta, can you mute your mic? Yeah. So basically we have this user behavior service, right? That's basically hook, and your analytics service hooks to that service whenever you're watching a movie and shit, right? It shows you what the user is. Then there is I can think of a recommendation service, right? You guys think like a recommendation, that will also hook to the, that hooks to the analytics service actually, right? When you think of it, right? Based on your analytics, right? In general, the analytics and the user specific analytics, or it can also hook to the user behavior service, because this is his behavior, right? The user behavior service has more particular data about the user behavior, while the analytics service aggregates the behavior across all users, so it's not really a particular user. I think it's better that we hook it to the user behavior service, and we build this recommendation service, right? Now when you think of it, user comes to this service, right? User hits up the user service, it gets the token, whatever shit, right? And he gets a session token. Then he comes to the recommendation service, he gets a list of movie IDs from the recommendation service. That also depends on the movies that are present in his cache. That there's a lot of parameters that you can think of, right? And once he gets the list of movies, and then it's basically displayed in his UI that okay, these are the list of movies. And then when he clicks on a movie, there is this movie service that hits this. If it's in the CDN, he streams it, or from the movie service it goes to the CDN, and then he streams the movie, right? This is kind of a high level overview of hotstar if you look at it, right? Does it make sense? Hello.
Yes.
Yeah, database and
Yes,
all,
yes.
database and all is
Yes.
easy, right? I'm not doing all those things. APIs also you can build, like once you have the overview, you can build APIs, you can build those databases and stuff, right? So I think this is good. Today we did two services, right? Would you guys want me to write the APIs? Like, is it needed, or do you guys think you can do it yourselves? Hello.
We can discuss for
We
this.
can discuss. Yeah.
Yeah, so user service is just the same, analytics and all is same. Movie services slash movie, that is a list of movies, right? It basically is just a stored for all your movies, right? It deals with all that. User behavior service is basically slash, see what the user has been seeing. If I can think of it, what are the APIs that are exposed? I can think of, slash user history, right? It gives out the entire user history, whatever he has been seeing, how much distance he has seen it, right? And I can think of something like user history and then slash um, update user history. So if he's watching a movie, right, what my system can do, what my use what my local device can do is it's going to pull this user behavior service again and again, and it's going to update the user history. Again, a good thing, because we talked about this, so again there's a queue that's going to come in picture, right? Because if a lot of users are watching a lot of movies, they continuously are going to hit this service to update that, okay, I've watched 2 minutes, I've watched 3 minutes, right? So you want to put all the data in the queue. You don't want to choke up the user behavior service. It's also not necessary data that needs to go into the user behavior service, right? Analytics service hooks up. There's a recommendation service, which very simple, very simple. It just hooks up to the user behavior service, and it's just going to take a slash recommend, right? Slash recommend. It's just going to take a list of recommendation, if you think of it, right? That's super easy, right? Whatever it's going to recommend to the user, that these are the top 10 movies he can see, or it could always be more complicated than that totally depends, right? It can give you polls like a score that, okay, this user is going to see this much, right? And then movie service is basically just it gives you a list of movies. Like if you send a movie ID, it's going to return you the movie, and it's going to return you all the metadata for the movie, right? How many likes the movie has or whatever. It can also maintain all those things like likes and all that stuff, right? But I think that should be it for Hotstar. It's a pretty simple system design, right?
Ramit, recommendation service will be dependent on user behavior service, right?
Yeah, it
Whatever
will.
user behavior service will update, next time the recommendation service will show that thing only, according to
Exactly.
that thing.
Exactly. So it hooks up to the user behavior service, like I said. Yeah, exactly. I think that's good, right? We have done two services. I think there's 15 minutes left. We can do like a
Just a question, Ramit.
yeah. Yeah, please go ahead.
Like, what Hotstar uses to in the live streaming when they are serving the content to crores of peoples?
Yeah, exactly. So that's a very different architecture if you think of it. Like I'll tell you, I have not studied a lot about it, but from a
Okay,
perspective, if you think of it, right, how does live streaming work? It's basically like video calling, right? Except you're video calling to millions of people. So you have data
okay,
that's like, let's just say this is data, right? There is this live stream that's happening. This data is being generated. It goes into the Hotstar server, right? And then it's just being broadcast to millions of people, right? It's a one-way communication. How does your Doordarshan work, right? If you think of that architecture, right? So what, again, this is my
okay,
interpretation. It's not the correct interpretation, right? It's my interpretation that this is how live streaming works. It's just like Doordarshan. Like there are these channels, right? There are these channels where there are these data packets, right? So all these CDNs will have this live channel data packet, where data packets are getting accumulated, and then you're basically just pulling the data packet just like a movie, right? So they anticipate all that. They
okay.
adjust it around that, right? So again, live streaming architecture is, how do I say it? I mean, it can be more complicated also, right? There are people who work on live streaming. Like, if you have to dive deeper, this is not how Hotstar is designed, right? It's very, very complicated than that. But if you're doing a interview, right, this is how what my interpretation is of live streaming architecture, right? Um, yeah, this is
Okay.
good, I think. Okay,
And
so
also one more question that if we have CDN, so what is the difference between having a CDN or using distributed databases?
distributed databases. So um, distributed databases are for data, right? I mean, again, I don't know
Okay.
how these two can be the same thing, right? A CDN is a cache. A
Okay.
CDN
Actually,
is a
I wrote in, I read somewhere in Medium blog only that Hotstar uses the distributed network for this streaming purpose.
yeah. So Hotstar can use anything.
I'm,
That's, this is my interpretation, again, that how I will build it, right? Like right now, there's some app that our company was working on, right? And they gave me a copy, and then I saw it, and then I sent it to my manager that, okay, is this how this is built? Because that was written in Scala, so I didn't read the code. And then he said, yeah, it's pretty much that's how we build it, but this is one way we can build it, right? So that's how you interpret things. So this is my interpretation. Again, distributed databases are like, I'm not sure what distributed databases are that much. Like, from what I know, it's just databases that are sharded and stuff, right? So that could be one way that they
okay.
have done it, right? For me, I think, whenever I think, again, the point is that you have to find patterns, right? Like, you learn a lot of things, then what
Okay.
happens is you're confusing those things, right? You know that, the way that I like to think of it, and like, I'll tell you this, that, I failed a lot of LLD interviews, I failed a lot of DSA interviews, but I've never failed like a HLD interview, because I have these patterns in my mind. Like, whenever someone tells of video streaming, I think of CDN, right? I don't think of distributed databases, I don't think of anything else. I think of CDN. Like, that's the only thing that comes to my mind. So that's how your focus is that you have to build it in 60 minutes, right? 30 minutes, 60 minutes, you have to come up with a database in 30
Okay.
minutes. Whenever somewhere load comes, you put a queue, right? This is how you build patterns, right? This is how,
Okay.
you're building patterns. So if you don't know distributed database, an interviewer is not going to ask you about distributed database, right? If you can give an implementation with CDN, then what's the issue with that, right? So again, like, learn some things but build patterns within those things, right? So that you are able to answer the interviewer's questions. Does that make sense? Hello?
Yeah, got it.
Yeah, yeah. So we did 2 questions today. I think this is amazing, right? So the goal, like, I'll tell you how the structure is, that over the next 30 classes, I think 3 are done, 27 more will be there on HLD. Every day we're going to do two questions, right? We're going to pick things up from lead code and solve real HLD problems. I expect that all of you should be able to find these patterns and do it. Like, you see how fast we did Hotstar, right? We just picked up a few things, did it within like 10 minutes or something, right? Completely ad hoc. So that's how we're gonna do things, right? So I'm stopping sharing. I think it was a great session. We'll have like 5 minutes of Q&A or something, right? About anything that you guys want to ask. Nothing. No one has anything to ask.
Hey Ramit,
Yeah.
Ramit, can you also post the question that you asked initially for generating test cases for a URL, like
Yeah. Yeah.
initially question?
That's what. So it's again something that we are doing in our team, and I kind of came up with an approach for that. So that's why I mean, I just asked that question. We can discuss it in chat, right? So it's a little, I think, complicated question, but again, these are some use cases that you think of, right? Of OpenAI. Like, let's just think of a use case, right? Like, you have scrapers, right? What scrapers do?
Essentially, scrape data from the internet,
Yeah,
right?
scrape data from the internet. So let's just say, Twitter did this ban thing, right? They banned scraping. Why did they do that? Because someone was scraping Twitter and he was creating his own Twitter, Like, do you understand that? That's how people used to create their own Reddit. Like, let's just say you have a very popular website, right? You have Geeks for Geeks or something like that. Now today you want to create your own Geeks for Geeks, right? So it's going to cost you millions of dollars because they have their article writers and stuff like that, and they have built that site. So what do? You basically build your own website. You create some APIs through which you're going to populate data, and then you scrape Geeks for Geeks. So overnight, you have a exact clone of Geeks for Geeks. Does that make sense? Right?
Yeah, that's
That's
insane.
how people do these things. They have limits, they have systems in place, but that's how people do these things, right? So now think of it, right? When you're doing scraping, right, you get a DOM object model, right? You get an HTML, right? When you're scraping a web page, you get an HTML if you're running in Puppeteer. If you're running in something like how do I say, if if it's JavaScript, then you initially will not get that image, right? But in Puppeteer you will basically get the raw HTML. Now you have to use a DOM parser or something like that to parse that HTML and get the data that you want, right? And now when you're doing this scraping, what you do, how scraping works is you are basically just seeing, you're going to Chrome and you're saying, okay, this is the DOM and this is the data part that I want. It falls under this part of the tree. So this is how I'm going to navigate that tree, scrape that data, and then get that data part, right? That's the way scraping works. Now what if I do this? What if I now that's unique for every website, that's unique for every blog, right? If you're doing scraping like this, you have to write that for every page, and then that page could change in structure, and then your entire code is messed up, right? So what if I did that? I just took that HTML to ChatGPT and said that give me what I want, right? I want this blog, give me this relevant part of data, right? ChatGPT would be able to give you that, right? There are OpenAI APIs that will be able to give you that. Make sense?
Yes, yes.
So you're essentially you build a scraper that you enter a URL, and it's going to scrape, and it's going to give you exactly what you want, right? Exactly the data that you want, you're getting that, right? So it can scrape any website in the world. You just need to pay a shit ton of money to ChatGPT, but it can scrape any website in the world. You're just extracting raw HTML, parsing it to ChatGPT, getting what you want, right? So this is a use case of ChatGPT. This is something very powerful that you just that we just discussed using ChatGPT, right? Like Gen AI apps, million dollar Gen AI apps that build like this on top of ChatGPT, right? You will see apps that will blow your mind, that are basically just a simple wrapper on top of ChatGPT, because that's how powerful that is. So these are use cases, right? When you that this is some, like what I said was also kind of a use case that I wanted you to think on. So yeah, that's that, right? And yeah, so no other questions, right?
Ramit, can you also, like in the coming courses, can you also talk about Gen HLD for Gen AI apps as well?
There's not much HLD in Gen AI. Gen AI, like whatever I've talked, like every company I've worked with, we are building something in Gen AI, right? Every company I've worked with, it's a very thin wrapper on top of ChatGPT. Very thin wrapper.
Okay.
Like you can literally write a one-page wrapper or something. It's no big deal. Like if you think of it, better just stick to normal HLD. Will do things that are actually asked in questions, right? Because and whenever you get stuck, right, whenever you see you're not understanding something, go back to lecture 3, right? That 1 hour read that we did on that one paper, right? Go back to there. That was probably the toughest session that you will have, right? Might be that if you understand that 100%, you'll understand everything else 100%, right? So go back to that, do that. And yeah, I'll just stop recording. I think we have had 1 hour.